is another problem type that you will have to know how to do. Now this is the reverse. What is given to you here is the wavelength of light that's being given out is already given. Alright? The wavelength of light is given. We know for a hydrogen atom the energy should transition, or the electron should transition to energy level 2. What they would like you to solve for is what is the initial level from which it's originating and landing at 2 if it's giving out a wavelength of that many nanometers. Does that make sense? Do you understand? Does everybody understand the question? So now we need to start with the equation delta E equals hc by lambda, or lambda equals hc by delta E, either or. So the wavelength is given. If the wavelength is given, what can I find out? Can I find out the energy? Yes. Alright. So I'm going to use this equation to find out, using my wavelength, what is the amount of energy transition it will involve. So that is 6.63 times 10 to the negative 34 joules second times 3.00 times 10 to the 8 meters per second. Alright? And my lambda is 410.1. Can I have my lambda in nanometers in this problem? I should have it in meters. So it can be times 10 to the negative 9 meters. Alright? If I just multiply it by 10 to the 9, it becomes so many meters. So now my seconds will cancel, my meter will cancel, and my final answer will be in joules. Alright? So let's plug it into the equation and let us solve. Alright? 6.63 So what did you get? 4.85 times 10 to the negative 19 joules. Yes or no? So, do you think this energy is being absorbed or this energy is being released? Is it being absorbed or released? Well, it looks positive, but isn't it making the transition to a lower energy level? Isn't that why the wavelength is being released? Right? So this was something that I made a mistake on, because after a year I was coming back and I did this mistake in my third period class. I need to remember to include a negative sign here. Yes, Madeline. Well, I just plugged it into my, do you want me to show how I used it on a calculator? Okay, let me pull up a calculator and do the problem. All right, so here is how I plugged my numbers into my calculator. All right, let me clear this. 6.63, it's to the negative 34, is that right? Times 3 to the power of 8, is that right? Divided by 410.1, and it's to the power of negative 9, right? Right, Madeline? And I hit enter, and that's the answer I got. Do you see e to the negative 19? Do you see that? Okay. Guys, so this is negative. Is that right? So I need to now use my Rydberg equation because only my Rydberg equation gives me the initial and the final energy level. Yes or no? I need to find out my initial energy level. Isn't that the objective of the problem? So in my Rydberg equation, my energy is 0.485 times 10 to the negative 19 joules equals minus 2.178 times 10 to the negative 18 joules 1 by, what is the final state to which it always comes? That's 1 by 4 minus 1 Ni squared. So I need to find out what is my Ni squared. Yes?
Why is the negative 5?
Because this is the energy released. So even though, you know how when we calculated going forward, from the energy we calculated the wavelength, we said it was energy released and we ignored the negative sign. When we are going back, when we are substituting in this equation, we need to remember to include it because otherwise we'll go wrong with our signs. And it is energy released. Energy released is always negative. Does that make sense? Even though it's not obvious in that equation, we know that it's energy released. Do you understand it? So now, I'm going to get rid of this number, alright? Negative 2.178 times 10 to the negative 18 joules. I'm going to get rid of this number. Alright? Are you with me? Alright? So I'm dividing both sides. So if I plug that into my calculator, alright, what do I get? I get 4.85 second E negative 19 divided by 2.178 negative 18. Is that right? And what is my answer? 0.222. Is that right?
Yes.
I'm going to keep it as 0.222 or 0.223, however you want it. Alright? 0.223 equals, are you all with me? 1 by 4 minus 1 by Ni squared. Now, for a moment, can I just get rid of this problem and use the space, guys? Just because I want to do the problem, alright? So that becomes, if I take my Ni squared to the other side, it's 1 over Ni squared equals, my 1 by 4 I can say is 0.25 minus 0.223. Yes or no? Yes or no? Is 1 by 4 nothing but 0.25? Yeah, I subtracted. When I brought it over to this side, it became negative. Right, Emma?
Because the positive point to choose when you brought it over to the positive 1.4. See, like in this equation, how it's equal here.
Alright? So is it 0.027? 0.027 equals 1 by Ni squared. Or I can switch these two and say Ni squared equals 1 by 0.027. Yes or no? Basic algebra. However you want to do it. 1 divided by 0.027 equals 37 almost. Alright? If you had not rounded it here, you would get 36. Alright? Doesn't matter. Alright? So I have 37 equals Ni squared. Now remember, Ni is an energy level. It has to be a whole number from which the transition is taking place. Yes or no? So the closest you can get to is 6. Alright? So your Ni equals 6. So from which energy level does it make the transition? It makes the transition from energy level 6. Do we understand this problem? You will get tested on this problem type. You will be given a wavelength and you will be asked to determine the energy level from which it's making the transition. Do you understand this problem type? Okay. So I'm glad I'm going to stop my video and I'm going to show you some demos now.